This is problem 11.1.5, and with this particular problem we're going to just solve for some basic sum of squares information, and then we'll also gather up the critical F score and the F test statistic towards the end here. So I want to show you how to solve this problem both with the data analysis Toolpak and XLStat. It's important that you use these resources in Excel because it will save you a lot of time and minimize errors. As you see from the textbook, the formulas for calculating out the sum of squares information is pretty lengthy, and just not something that you really need to spend a lot of time calculating when you've got Excel at your disposal. So to solve this problem with the data analysis Toolpak, this is really the simplest way to do this particular problem. You notice that I've got the data already typed into this sheet here. So we've got 4 different levels or 4 categories of data in this one-way ANOVA problem. And I manually typed it in because it's pretty quick to do. There's not a lot of observations or data points. I could have used this icon here within the problem to export the information to a new Excel sheet if I wanted to. Again, I just manually typed it in. For the data analysis Toolpak, just go up to data and over to data analysis. And here we've got a number of different statistical tools that we can use. For this problem, we're just using the most basic one, which is the first one, which is the single factor or one-way ANOVA. I'm going to click on that and get our ANOVA table. And our input range is just the actual table, which you see already highlighted on its own. If this was blank, you just simply leave the cursor there and highlight it, including the column labels. And notice that the labels in first row is already pre-filled as well for me. And my alpha defaults to 0.05, which is correct for our particular problem. And the output range can really be anywhere as long as it doesn't cover up something that you already have in there, something that you need. So this one, it's already defaulted to A13, so that's right about here. That's fine. I'll just leave it. I don't have to actually put in a whole range of cells. I just put in the first cell that the uppermost left point that it would start, the output would start in. And just know for XLStat, when you are working XLStat, I'll bring it up again when I show how to solve it with that application, that with XLStat we want to choose a new worksheet as opposed to pasting the output onto the current sheet that we're in. And that's just because if we make a mistake or for whatever reason need to rerun the analysis, it's kind of a pain to delete the various parts of the XLStat output on your sheet. It's easier just if it's on a separate worksheet, you can just delete the whole worksheet by going down. And you can't see it on the screen, but if you go down to the tab that we're on or any tab, you can just right click the mouse and just delete it. So for data analysis, we'll just keep it on the same sheet that we're working in. And that's really it. So hit OK. It's going to provide us with the ANOVA table. And this has all the information that we need for this problem. So it has our sum of squares column here. This is the sum of squares between groups, so SSB. And this one is the sum of squares within groups, so that's SSW. And this is our sum of squares total, SST. So these are all points of information that we're going to need for this problem. So just kind of skipping around, the first question is the sum of squares total, which is here in the 238, and then broken up in between the sum of squares between and the sum of squares within. Now those here, we have our degrees of freedom as well associated with each one, and then our total degrees of freedom here. MS is the mean squares, mean squared between, mean squares within. And then we've got our F statistic, which is asked down this part here, 6.614. Note that that's calculated by the mean squares between divided by the mean squares within. That's another way that we can calculate it. So if we had this information, but we're missing the F statistic, we could calculate it manually ourselves. And then jumping over to the critical value, the F critical value, that's calculated for us as well within the data analysis Toolpak. And when we use XLStat, it does not calculate this, but we can use an Excel function to calculate it very quickly. Go ahead and just do it here for you. We use the FINV RT. Remember, this F distribution is a right skewed or upper tail distribution. Our probabilities are alpha, so probabilities of 0.05. The degrees of freedom, so D sub 1 is the degrees of freedom for the SSB, and degrees of freedom 2 or D sub 2 is the degrees of freedom within groups, which is 10 in this case. And that will give us our F critical score as well. So another way to calculate an Excel function in case we are needing to use XLStat, or if we were working in a more advanced application that may not provide it as well. Because with this type of testing, and also when we get into regression analysis, what we typically make these decisions with, these accept or reject null decisions, are with really a p-value. So in this case, our p-value is 0.01 if we round to 2 decimal places. This question does not ask for it, but it's always going to be given in the ANOVA table. So just remember that you can make the decision about accepting or rejecting the null either way, either via the critical score or through the p-value. So if we were going off of the F test versus the F critical score, then we would reject the null because the F test is greater than the F critical score. The other way to look at it through the p-value approach is we would say the p-value is rounded to 0.01. Show that for you. So 0.01 if we were to round to 2 decimal places. And that figure is less than our alpha of 0.05. So when we have a p-value that's less than alpha, that's another way that we know to reject the null. So how can I do this with the XLStat application? So before I pull up XLStat, I need to make one adjustment to our table. So XLStat is a little, I don't want to say picky, but in the way that we select our range of data or observations, we need to have a cell here in the upper left corner or just next to the table. This can be essentially a title cell, so it could be the title of the factor that we are investigating, so whether it be customer satisfaction or time playing video games, whatever it is, we need to have something here. It can be anything, so we can just use even the problem number. And this is just one adjustment we need to have in order to work with XLStat. So what I would do is come up to the XLStat menu here. I'm going to choose modeling data and just go down to ANOVA. And if you've worked in XLStat already, or if you've worked in ANOVA or whatever application you're using, it's going to have some information that's already been in there from your past tests, or it may have some buttons selected or deselected from past tests. So the very first time you go into the ANOVA screen, you're going to have a lot more stuff selected than probably what you'll see here. And I'll give you some examples. So the data format, certainly in our cases, we want the table format. And when you see it already pre-fills, selected our entire row or table set, including the new cell that I created with the title. And very important that our number of factors, this is a one-way ANOVA, so the number of factors is 1. And our output is going to be on a separate sheet. Like I said before, best with XLStat to just have it come onto a separate sheet. You'll see it go right next to your whatever sheet you're in down at the bottom. I know you can't see it on the screen, but if I have a problem number in one sheet, then the ANOVA output is going to go on the next sheet. Aside from that, the next most important thing is within the options that we have the correct alpha and that we have the correct number of levels. Remember, this is we have 4 levels here, so it already has 4 in there, and so we're good there. And all this other stuff, most of it we don't really need this, especially with the basic problem that we are working with. Outputs, first time again that you come in here, most of this will be selected. You can deselect a lot of this stuff just to kind of minimize the amount of output that this XLStat is going to provide for you. And you see there's a little bar up in the upper right hand corner here. There's another tab, which is the charts tab. Again, this first time you come in here, this is all going to be selected, so you can just deselect all this. You don't need any charts, certainly for this problem. And so we should be all set from here. If you look at this means tab, we're not doing a 2-key Kramer test on this particular problem, but we'll do it on the next one. But you can see that it's found here, but it's been deselected. So I'm just going to hit OK. And you can see it has created a new sheet for me. And it has our information here. You see it matches what we had before with the F statistic. Again, the XLStat is going to provide output, a lot more output than what we really need for a lot of our problems. What we're looking at really is just the ANOVA table, and this has the same degrees of freedom. Note the label's a little bit different, so degrees of freedom for the sum of squares between is entitled model, a sum of squares within is titled error, and the total sum of squares is titled corrected too. And our mean squares, our F statistic, and our p-value is the same, 0.01. And then notice that there's no critical F score here. And again, we can just use that Excel function to get that figure if we actually need it for a problem. Like I said before, most of the time, the p-value will be what will be used to interpret whether we accept or reject the null. So that's how to solve this problem with both the data analysis Toolpak and XLStat. If you can get away with just using the data analysis Toolpak for whatever problems you can, it's obviously the kind of the cleaner, easier way to solve problems because it's not going to ask for as much information. But there are certainly going to be times where we need to use XLStat, and so we have that as an option as well.